Hey, in this video lecture, I'm going to cover three main topics. I'll first talk about self-ask prompting, I'll describe what it is, and explain why it works better than chain of thought. I'll then talk about something we call the compositionality gap, which is when a language model knows two facts, but is unable to reason about them. And then lastly, I'll talk about our self-ask plus Google Search system, which is a really cool and very simple retrieval augmented language modeling method for doing very complex question answering. It's like only 50 lines of code, but it's able to answer extremely tough questions by combining GPT and Google Search. So yeah, I think this talk is super exciting. Let's get right into it. So for this talk, I'm going to define a language system to be any computer application that has a language component to it. So Siri, Google Search, Translate, ChatGPT, these are all language systems. And today, it's pretty clear to everybody that language models are critical to language systems, right? Each one of these things is either just a language model or somehow uses a language model. Google Search uses BERT, which is a mass language model. But yeah, language models are a core component. They're going to become more and more important in the future. So improving language models is super important. There's no debate about that. And what we've seen over the past few years is that when we increase the size of these language models, they improve over many metrics, right? So GPT-3 showed this, lots of other papers showed this. And so here's a proposal for solving NLP. Let's just increase the size of the language model. So it's not easy, right? This is kind of an engineering-oriented proposal. Engineering isn't easy at all. I'm not saying it's easy, but it's just a different approach than the scientific approach of trying to find new methods and architectures that will improve these models. And I don't think that a pure engineering approach will work, because over my entire career, I've shown that a lot of properties of language models actually don't improve with scale. And in this talk, I'm going to talk about self-ask, this paper that I wrote, and we'll show an issue with GPT-3, and we'll show that as we look at larger variants of GPT-3, this issue gets worse. Okay, and this is a paper. Okay, so to start off, I'm going to define knowledge. And in my view, the knowledge in a model is its ability to recall facts that it saw multiple times during training. And so if we wanted to test for knowledge, we can just ask it questions about things that we think it saw lots of times during training. Like, what's the birth country of Plato? What's the calling code of Greece, right? But systems that are only capable of retrieving existing knowledge are very limited, right? If we're deploying like Google Search or Siri or ChatGPT, it's really important to get it to answer kind of things that it's seen many times in the past, right? Like a lot of times I just want to know, like, how many feet are in a mile? I don't know. How many, I don't know, what's the distance from the moon to Earth? Like, a lot of my questions are things that people have already asked before, but a lot of my questions are things that have never been asked before. And so in order to provide reasonable responses to things we've never seen before, I think we need a bit of reasoning. And in my view, reasoning is the ability to combine two things that you've previously seen independently before. It's the ability to combine those two things in a way you've never seen them combined. And so testing for reasoning is going to be a bit more challenging, but because we wanted to test GPT-3's reasoning abilities, we devised this new training set where we're going to ask it questions that require combining two pieces of information that it knows
in a way that it's never combined before. So for example, we're going to ask it, what is the calling code of the birthplace of Plato? Right? So it's seen where Plato was born probably thousands of times. It's seen the calling code of Greece probably tens of thousands of times. But now we're asking it to reason about those two facts in a way that it's never seen before. And I actually went on Google and tried in all kinds of ways to figure out if anybody's asked this question before, and I don't think anybody has. Right? So this is, when it answers this correctly, it's really doing some very basic reasoning. Yeah, so here's what our kind of testing environment looks like. We're always going to give it one or a few example question and answer pairs, right? So our testing question here is, what is the calling code of the birthplace of Plato? But then our example question answer pair is, what are the calling code of the birthplace of volunteering? And then we have the right answer plus 44. So everything here is stuff I've typed. And now I'm going to press submit. And then the green highlighted text is what GPT-3 outputted. And it answered correctly. The calling code of Greece is plus 30. And yeah, when I first saw this, I was really surprised. And I couldn't really believe it, because I've been working with language models for a really long time. And for the longest time, I feel like up until a year or two ago, we had a really hard time getting them to just regurgitate the stuff that they've seen billions of times. Okay, I'm exaggerating, but we had a really hard time getting them to do very basic things. And now not only does it know that the calling code of Greece is plus 30 and that the birthplace of Plato is Greece, it's able to do this reasoning that it's never seen before. This is like a major step forward for language models. And I was only convinced that they were actually slightly capable of doing very basic reasoning only when I saw this example. Because until then I was like, they probably, right? Like people would show me like, write, this news article in the style of Shakespeare. I'd be like, it's probably copying from somewhere in the training set. But I don't know, for some reason this really convinced me. Yeah, so we made a dataset of these questions. It's called Compositional Celebrities because all the questions are about celebrities, because we think celebrities are people that are really talked about a lot on the internet, right? And we want to ask compositional questions that compose facts that have seen been seen many times before, right? So celebrities are a good topic for that. So we have questions like, who won the Nobel Prize in Literature the year Matt Damon was born? What is the currency abbreviation of the birthplace of Kofi Annan? So GPT-3 gets a lot of these correctly, but it doesn't always answer them correctly. So this is GPT-3, this is DaVinci 002. And so here's a question that it's going to get wrong. So the question is, who was president of the US when Billie Eilish was born? And it answers Barack Obama, which is incorrect. The right answer is George Bush. And so you might think that it's answering this wrong, either because it doesn't know when Billie was born, or because it doesn't know who the president was on that date. But actually, we can go and test this out, right? So we can ask, when was Billie Eilish born? And it gets that correct. And we can ask, who is president of the US on that date? It gets that correct as well. And so there's a reasoning bug here. GPT-3 knows these two facts independently, but it can't do the very basic reasoning required to answer my compositional question correctly. So yeah, that's pretty surprising. It's very non-human-like behavior, right? If I know two things and then you ask me a very basic reasoning question about them, I'm going to be able to answer that correctly. But yeah, GPT exhibits this kind of inconsistent behavior. And so the first thing that I'm going to show you from the paper is a more empirical exploration of this phenomena. So we're going to take our 8,000 questions from compositional celebrities, right? So there are these compositional questions, and we're going to ask each of these questions, the compositional questions, right? Who was president of the US when Billie Eilish was born? And Da Vinci 002 is going to get, I think, 30% of these questions correct. Right, this is the largest, Da Vinci is the largest variant, 175 billion parameters. Oh, actually, this is just Da Vinci. This is not 002. This is a regular. This is a non-instruction tuned model. Anyways, now, just like we did for the Billie Eilish question, we can take each of these questions apart into the two sub-questions that make them up, and we can ask each sub-question by itself, and we're going to consider GPT-3 correct only if it gets both sub-questions in the pair correct. So just like we did for the Billie Eilish question, we take each compositional question, take it apart into two sub-questions. We consider it correct only if it answers both sub-questions correct. And when we do that with Da Vinci, the accuracy is like 50%. So there's a gap here. There's a whole bunch of questions for which GPT-3 knows the two underlying facts, but it cannot do the very, very, very basic reasoning required to answer the compositional question. And that's what we call the compositionality gap. And in this model, it happens for 40% of the questions. So for 40% of the questions for which we can answer both sub-questions, we can't answer the compositional question. So this already is very surprising. And by the way, GPT-4 still has a gap, and it's significant. It's smaller than this, I think, but it's significant. So this has absolutely not been solved. So this is already surprising. But the kind of more surprising result here.
There's a question.
Oh, yes, thank you.
Hey, so I guess my question is, why would we expect the language model objective to allow for reasoning? Because the language model objective is simply predicting probabilities of next token, which doesn't, there's no explicit requirement that it actually does any reasoning in order to do that.
There's no explicit requirement for anything other than predicting the next word, but I mean, it's a good question. But so first of all, there is reasoning that is being learned, and I think that it's being learned because having better reasoning skills improves your ability to predict the next word, right? That's why it's probably learned to do a lot of reasoning, and that's why it was able to answer 30% of these that's a significant chunk. It's able to answer 30% of these questions, and it's never seen them before. It's never seen, Aristotle's birth country's calling code is +30. It's never seen that, but it's able to answer that because it's had to develop reasoning abilities, because it's realized that if you're better at reasoning, you get better at predicting the next word.
Could it just be due to things that are close in context? So when you bring up Plato, probabilities then shift such that things related to Greece might go up in probability. Therefore, when it is looking to predict the next token, it's willing to say like, hey, I know that I got to predict a calling code. Which one is closest semantically in some sense when I've seen these other tokens in the past? So like in some sense, you're pulling in some context that may or may not be relevant. Like maybe in the Billie Eilish case, it's actually incorrect because Billie Eilish didn't become popular maybe until the Barack Obama age. And so when it looks at probability is higher that Barack Obama is mentioned when it's not having to do any explicit compositionality separation.
I think I've lost, like, okay, so what is your new question? Like, or what is your statement?
I guess the statement is it possible that it's not based off of reasoning? It's still just based off of probabilities. And the way that
Everything is probabilities. The word reasoning, I guess it's really hard to define, and when it's reasoning, it's probably not doing whatever we're doing in our brain. I don't know if it's interesting to get into that, but the bottom line is that I kind of have this definition for reasoning and this ability to combine things in a way you've never seen them combined before. And GPT-3 manages to do that pretty well. It's not perfect, but it does it really, really well. And is it because, like, I don't know, the context is this? Yeah, whatever. It could be, there's lots of reasons for why it could be happening, but the bottom line is that it's happening. And as we'll see in a second, it's actually the reasoning ability improves as you increase model size.
Okay, thank you.
Yeah.
There is another question, actually two
Yeah.
other questions, so maybe Mohit go first.
Yeah, I have a just quick question on this plot.
Yeah.
Are you assuming that if the model answers both the sub questions correctly, then it also answers the original question correctly?
No. So if you answer both sub questions correctly, you get a point for the green dot. If you answer the compositional correct.
But do you ask the original question again after you ask both of the sub questions? Because it could get.
Yeah. We don't do that here. Here we're either only asking it the compositional question, or we only ask it the two sub questions.
Okay, so yeah, there's still, even if it gets both of those right, it still may not be able to answer the original question. Although I guess it's unlikely, but yeah.
Yeah, but we'll talk about that in a second, because self-ask is going to be exactly that. It's going to be decomposing a tough question into sub questions and then using that to answer it. Yeah. And then there was one other question.
Yeah, there is one question in the chat. For all the people who are online on Zoom right now, like if you want to ask a question, just like raise your hand and unmute yourself. Maybe it will be easier than me just reading those questions in a very non-fluent way. But the question is, are the answers for both sub questions and the compositional question generated multiple times and the most common chosen, or only once?
No, we only do it once. I know that there's some methods that, like, generate things a bunch of times, but we only generate once. And it's also because we're using temperature equals 0. So there's only one possible thing the language model is going to say, right? If we would regenerate with temperature equals 0, we would get the exact same answer. So somebody asked, are there questions for which the compositional answer is correct, but the independent answers are wrong? So yeah, we talk about this a tiny bit in the paper. You can see the numbers for that in the paper. The actual answer is that yes, it sometimes happens that the model gets the compositional question correct with the independent sub questions wrong. But when it does happen, I've looked into it, and it's always because of some silly technical formatting issue. So for example, you know how in Spanish there's the N with a diacritic thing, like the niño, like the small dash on top of the N. So sometimes, like, we could ask GPT like a question where the answer has that, that weird N. And so in the sub question, it'll forget to say that, so we'll consider that wrong. But in the compositional question, it will say that, and then we'll consider that right. And so it's just those silly types of issues. But other than that, it doesn't really happen. Last questions on this slide before we move on.
I think we are good.
Okay. So the even weirder thing about the compositionality gap is that it doesn't shrink as we increase model size. So between 1 and 175 billion parameters, it stays at around 40%. And by the way, even in ChatGPT, it's at 40%. I guess we don't know. So we can't run these experiments anymore because we don't know how big ChatGPT or GPT-4 is. And ChatGPT may actually be smaller than 170. It's probably smaller. But so we're going to focus on GPT-3 here. For GPT-3, there's this really cool thing where you can get different, in the API, you can specify which model variant you want. And so what we can see is that, yeah, it stays at 40%, even as we increase model size. So as these models become bigger, they can answer more of these sub-questions. They can answer more of the compositional questions, but the gap is 40%. So scaling doesn't solve this. So we're going to solve this by adding guidance. A solution is called self-ask, and it's very simple. I'm really excited about the solution because it doesn't require more training data. It doesn't require fine-tuning. It simply requires changing the prompt. And here's how it looks. So before we had a question, and then we immediately had an answer. And now we're going to do something a bit different. We're going to have a question. So this is our example that I wrote manually. Then we're going to say our follow-up question is needed here, and we're always going to say yes. And then we're going to say follow-up, when was Justin Bieber born? Right? So we're trying to answer who's the president when Justin Bieber was born. So first sub-question, when was Justin Bieber born? And then I wrote the answer. And then the second sub-question, who was president of the US on that date? The reader answered Bill Clinton, so the final answer is Bill Clinton. So now we're asking the model to kind of think things through before it answers the question. So in the paper, we kind of call this an elicitive prompt. And the only other elicitive prompt that I'm kind of aware of is chain of thought, or like the main thing that you guys will have heard of. Right, in chain of thought, up until chain of thought came around, we would always be like, okay, question, okay, what's the answer? But a lot of times it really helps the model to think things through before it utters an answer. Humans can think in their head without saying anything, but a model can't. It's very limited in how much thinking it can do in one time step. So if you want to let it think things through, you have to ask it to talk that thinking out loud. And so chain of thought is great for improving performance, but our method, and we show this in the paper, is even better than chain of thought. And I think I'll show an example of that in a bit, but first let's see how our model does. So this is the prompt. We click submit, and then it types all of this automatically. So it automatically says follow up, when was Billie Eilish born? It answers correctly. Then it says follow up, who was president of the United States? It answers that correctly, and then it says, so the final answer is George W. Bush. And this was all generated by the model. So by getting
question, if it's okay.
Yeah, of course.
So do you have any question pairs where you use different reasoning between them? So this one has very similar reasoning, which is...
Yeah. It's a good question. Yes. In this example, you're right. So the question that I'm asking here is very similar to the input question. So this is a very easy example. But in the paper, we're not this nice to the model, and we have lots of data sets where our prompt questions are very different from our test time questions. And we can play around with this. I think we'll have a bit of time to do some demoing in a second.
Did you do any looking at questions where the reasoning was similar versus different, and if there's a gap in its ability?
Yeah, that's a good question. It's definitely, I mean, as these models have improved, it's relying less and less on the prompt. And like it can answer questions that have very different reasoning than the ones it sees in its prompt. But I was pretty impressed, and it was pretty good at answering questions that had very different reasoning than the ones that it was presented within the prompt. And there's a bunch of prompting literature that talks about how you're not really learning anything from the prompt. The prompt is only kind of showing you the structure for the answer. And I really believe in that. So we didn't invest, you asked a really good question. We did not spend enough time investigating that in the paper. I think it would be a cool thing to try and understand more thoroughly, but I don't think the prompt is kind of for teaching them all how to reason. I just think it's for showing it the method. And so,
Okay.
yeah, sorry, I'm blabbering on and on, but yeah,
Thank you.
it is able to do different reasoning than what it sees in the prompt. Yeah, next question.
Seems we are good for now. So.
Okay.
Sorry, I just have one quick question, if I can.
Yeah, go for it.
So I think you mentioned, I think chain of thought. I was also wondering, like, if you had any comparisons with least to most prompting as well, because I think some of the ideas here seem, I think there's some overlap with how problems are decomposed in least to most prompting and then iteratively and intermediately solved. And then I think those are re-injected into the prompt.
Yeah, if you send me an email, I can send you the new version of the paper, which has comparisons to least to most. And least to most is just like 30% slower, and it performs just as well or worse than this method. So yeah, it's just inferior. It also has to make multiple forward passes, whereas we make one forward pass. But yeah, you can send me an email and I'll send you the new version of the paper.
Sounds good. Thanks.
Yeah, I'll just talk about, because I don't know if I have a slide about this. So chain of thought is exactly this, just that chain of thought doesn't ask the follow-up question. So chain of thought will only have what we label as the intermediate answers, right? So if we ask chain of thought, who was president of the US when Billie Eilish was born, it'll just say, Billie Eilish was born December 18, 2001. The president of the United States on the day was George W. Bush. So the final answer is George W. Bush. So it doesn't have this explicit structure of explicitly stating the sub question and then explicitly answering it and then stating the next sub question and then answering it. And what we noticed is that chain of thought a lot of times loses its train of thought and kind of just forgets where it was going. So, for example, in the paper, in one of the figures, we show that we asked the model, with chain of thought, we asked it, who was president of the US when superconductivity was discovered? And the model was like, so this is using chain of thought, superconductivity was discovered in 1912. In 1915, the president was Herbert Hoover. So the final answer is Herbert Hoover. And I'm like, no, that's incorrect. And then with self-ask, because we're explicitly having it state the sub-question and then answer it, it gets that right. So sometimes when you have this kind of unconstrained, very long generation of chain of thought, the model just forgets what it's doing and does really silly stuff. Even GPT-3, like Da Vinci 002. So yeah, having like this explicit rigid structure really helps the model remember where it's going. Okay. I don't know if we have enough time for a demo. Let's do a quick demo because this is just cute. Can you guys see my screen?
Yes.
Okay, so a lot of people ask me, can it do 3-hop question answering? And it can, especially if so it can sometimes do it even if your prompt has 2-hop questions. But now I have a question here that's 3-hop. This is totally artificial, but it's just fun to look at. So my example question is, who is the wife of the US president that served in office when Billie Eilish was born? And I asked 3 follow-up questions and answered them, and I said the answer. And then I have a new question here. What was the occupation of the brother of the person who gave the I Have a Dream speech? And we're going to use Da Vinci 00. So this is a GPT-3. That's not even GPT-4. And we're going to press submit. And it asked 1, 2, 3 follow-up questions. And yeah, it said the right answer. So this question is very artificial. It's not realistic, but it's just fun to see it solve 3-hop questions. Yeah, we might come back to this, to more demos if we have more time, but let's continue for now. So the really cool thing about this explicit guidance, the structure of our prompt, is that it really allows us to combine search engines with this language model in a very easy way. So I mean, at this point, everybody is very aware of the power of language modeling in search because of Bing search. But we wrote this 5 months ago, before that was out. And I think this is still a pretty cool way to combine language models and search. So yeah, let's see how we did it. So we call the system Self-Ask with Google Search. And here's why we did it. So language models have limitations, right? They're super expensive to train. And so we train new ones very, very rarely. It's going to start changing soon, right? We're going to train them more and more often as hardware becomes cheaper and stuff. But even if we train them once a month, they're not going to know about recent events that have happened in the past few days. And they're definitely not going to know about real-time data, like what's the weather in New York right now, what's the stock price of Facebook. Search engines do know about all of these things, but search engines have a really tough time understanding complex queries. If you've ever asked Google a compositional query, you probably know this, and I'll show some examples in a bit. But we're going to combine search with language modeling to get the best of both worlds. We're going to get the compositional understanding that language models have, and we're going to get the access to massive amounts of current information from search. And to present the system to you, we're going to walk through how it answers the following question: what is the current time in the country that won the World Cup? So that's a question. And so we're going to use the same prompt that we were using before, and we're going to feed it into GPT-3. And we're going to first ask it the follow-up questions needed here, and GPT-3 is going to say yes. And GPT-3 is going to say, follow up, what country won the World Cup? And then our system, I'm calling it a system. This is 50 lines of code. It's all on my GitHub. But this system recognizes very easily that a follow-up question has been asked because the words follow up have been uttered. And so we pause GPT-3, we tell it to wait a second, and we easily parse out this question, and we send it off to Google Search. And Google gives us this long paragraph. There's a tournament that's been held every 4 years, blah, blah, blah. At some point, it mentions that Argentina won. But it's a really long paragraph, and we take all of this stuff and we feed it again into GPT-3, and GPT-3 utters the following sentence, says, follow up, what is the current time in Argentina? So it has correctly parsed out Google's response, and it has correctly asked the next sub question. And so again, we notice that a follow-up question has been asked. We tell GPT-3 to hold on. We take this sub question, ask it to Google. Google says 11:12, and so we feed back into GPT-3 everything that it said until now, and we append intermediate answer 11:12 p.m. to what we're feeding into GPT-3, and then GPT-3 says, so the final answer is 11:12 p.m. Yeah, so that's our system. I'm really, really excited about it because it manages to answer complex questions that Google and Siri can't answer by themselves. And it's the first approach for language modeling and search. And up until now, it's the only approach that doesn't require reinforcement learning or extra training data at all. So there's a bunch of papers that have combined. So Bing search was not the first system to combine language modeling and search. There've been a bunch of papers about this, but our method is the first one that doesn't require reinforcement learning, doesn't require human annotations or any kind of extra training data. And it's also the only one that's open source and online. Yeah, so I'm really excited about it. And it's on my GitHub. You can go play with it. It's super fun. And yeah, it just uses this self-ask prompting. And then when it sees a question, it just goes to Google and asks it and gives GPT-3 back the answer. Yeah, I'm not really going to get into this, but we show in our paper that self-ask does better than just asking a question and then asking immediately for the answer. If you put Google in, it does even better. As I said, we also surpassed chain of thought. Yeah, I'm not gonna demo. I don't think we have enough time for the demo, but do you guys have any questions about this Google search system?
So it
Okay.
doesn't seem like there are any questions for
Okay.
people here in person. Anybody on Zoom?
I can ask a real quick one.
Okay.
Have you looked at using the ChatGPT plugins at all to try to put something out that people could use? That seems like it'd probably be very popular.
I'm still on the waiting list for the plugins, so I can't do that yet.
So you
But-
are planning it then. Okay, sounds good.
But yeah, you can go play if you have a GPT-3 API key. It's just an IPython notebook. It's like 50 lines of code, and you can play with it right now. It's really simple. For sure. Can a 3-hop question be answered if you only provide a 2-hop example? So yeah, that's a good question. And the answer is that sometimes it can. And we can actually let's try it out. So the question was, will the model be able to answer this question even if we only give it 2-hop examples? So I can go here and I have a bunch of 2-hop examples and I'm going to ask it. So all of these examples here are 2-hop. And now I'm going to ask a 3-hop question. Sorry. So this is Da Vinci 002. I don't think it will work with 002, but I think with 003 it might work. Oh, it worked. 1, 2, 3. Yeah, it worked. So yeah, there's the answer. But in my experience, it sometimes works, sometimes it doesn't work. And yeah, you also asked if it can do questions with different reasoning than what it's on the prompt. Somebody else asked this, but yeah, it can, because these questions are all 2-hop, and none of them really talk about politics, or none of them have this exact type of reasoning, and then it's able to answer this question.
There is another question.
Yeah, go for it.
Just let me know if you can hear it, because the mic is a little bit far.
I just want to know, what information do you include from the search result? Is it the featured snippet, or is it the first para from the first link, or have you tried any combinations of the first 5 hits?
That's a very good question. We go on Google and we ask something like, if you ask a question, it'll have this thing. So we parse that out. If it doesn't have this thing, we parse this out. And if it doesn't have any of these features, then we take the text from the first organic result.
Okay.
Yeah, so it's very, very, very basic. Like when GPT-3 is interacting with Google in our system, it doesn't have access to any of these results. It doesn't even have access to any web page, right? The most it can get is the snippet of the web page that Google chose. And it still is very, very strong and is able to answer a lot of questions. But it would be very easy to make the system much stronger by actually letting it click through into a web page and explore an entire web page. But yeah, even this very basic system that's only able to kind of browse the web through Google snippets is still able to answer a lot of questions. Somebody asked how much does stuff ask close the compositionality gap? It totally closes it, right? So the compositionality gap is there's a gap when a model knows the answers to sub questions, but not to the full question. But we're decomposing full questions into sub questions, and and so when we can answer the sub questions, we answer the full question. And in the questions that we looked at, the reasoning is very, very basic. So it's always able to correctly decompose compositional questions into their sub questions.
And I think there's somebody with hand up, if I can see correctly.
Oh yeah,
Yeah.
you can go and ask.
Sure. First of all, thanks, Ofer, for presenting this work.
For sure.
It's-
And I'm still not done. There's still like 5 more minutes of time. But yeah, go ahead.
Oh, okay, sure.
Yeah.
I have two small questions.
Yeah. Go for
First
it.
one is like there's no mention about the zero shot case here. Is it does this approach not work for the zero shot setting?
That's a good question. So as you guys know, there was chain of thought, and then so in chain of thought they have a prompt, and in the example you have example chain of thought reasoning chains. And after chain of thought came out, so chain of thought is a one or few shot method. Chain of thought is not a zero shot method. But after chain of thought came out, let's think step by step came out, and let's think step by step is also known as zero shot chain of thought because it's a zero shot way to get the model to think things through, right? We're not going to give it any examples. We're just going to say think step by step, and that leads the model to think step by step. So I think it's usually not as good as chain of thought, and in our paper we show that let's think step by step is not as good as chain of thought, but it's a really it's pretty close, and it's really cool to be able to do that zero shot. And so after we put our paper out on Twitter, one of the let's think step by step authors came up with zero shot self-ask. So I'll have to find this. I can't remember exactly what it's like, but instead of having like, you know, a question answer prompt, it was like it was something like answer the following question by first breaking it down into sub questions. So output like sub question 1. So I think it looked something like this. So let's try it out. So I really have never tried this, and I don't think it'll work, but we can try. Let's give our model a shot here with 003. Oh, wait. I had this inject going on. Yay, it worked.
Wow.
Wait, let me ask a question that we know is hard for it to answer. Can you guys see the text or is
Yeah.
there you go. Yeah, it works.
Wow.
Yeah, it's really cool. I'll play more. Okay, I just want one more. Who was president? We should put this in the paper because it's not in the paper right now, but it's really fun. Oh, okay, this is wrong. Yeah. It starts by asking who was president of the US. That's funny. Okay, yeah, sometimes it doesn't work, but yeah, it's pretty cool. Any other questions?
I had a second question also.
Yes, go for it.
So like you mentioned that the self-ask paradigm can be merged with the search engines to make better retrievers, and we can combine the reasoning part of self-ask with the search engines for better search queries.
Yeah.
But my question is there any applicability which you could think of this self-ask paradigm to areas other than retrieval? Like, let's say one thing which I had in top of my mind was we can build great human annotators out of this, great ChatGPT annotators by providing reasonings, follow questions, reasonings, and we can, given an example for a text classification task, explain the reasoning behind why.
Yeah. Of course. We're using self-ask to answer like algorithmic questions. You can use self-ask for anything. I think it's just a slightly better, or it's a better chain of thought because it explicitly asks sub-questions. So it just has, the model is better able to do chain of thought style thinking, but you can use it for anything that you can use chain of thought for.
I see.
We focused on question answering in this paper, but you can do anything you want with it.
I see. Thank you.
For sure. Let me just do a few more slides. I'm not really going to get into this. Okay. We have this cute thing in the paper called Bamboogle. It's a data set of questions that bamboozle Google. So it's a data set of questions that Google gets wrong that I manually came up with my master's student, Muru. And not only are these questions that Google doesn't answer correctly, it's actually questions where Google gives an answer which is wrong. So for example, if we ask Google, who is the father of psychoanalysis, it says Sigmund Freud. So not only is it not giving the right answer, it's also giving a wrong answer, right? Because I'm asking who the father of Sigmund Freud is. Or who was the head of NASA during the Apollo 11 mission? It says Eugene Kranz, but he was not the head of NASA. He was the chief flight director for Apollo 11. So it's pretty easy to trick Google with compositional questions, and it's pretty easy to ask it questions where it gets so confused that not only does it not give you the right answer, it gives you a wrong answer, which is even worse than not answering. And so, yeah, we have a data set of these questions and we evaluate our model on it. And so, yeah, Google gets 0 accuracy on this data set by design. And I think self-ask plus Google search gets like 60%, right? Which is pretty cool. Yeah, let me talk for a few minutes about my vision, and that's going to close this presentation. So I'm trying to make humans more productive by integrating language models with other software applications. And in the near future, I think we're going to see language models integrated into basically every app there is. And so if you're managing a bunch of stores and you have this Excel spreadsheet and you have revenue and expenses and you want to make a column for, profit or whatever, right now you have to kind of program Excel, but if you don't know how to program, you're out of luck. But I think in the very near term, we're going to have systems where you can just say, hey, please add a column for profits, and then in like a second, it just does it. But in the long term, I'm super excited about what I call automated research, which is the ability to kind of answer really complex questions using search and language modeling. So the example that I like talking about is the year is 2054, and a new virus has just been discovered. It's called COVID-54. And I want to type in, can any medications taken by pregnant people increase the deadliness of the recently discovered COVID-54 virus? And then within a few seconds, it gives me like a well-researched response with citations. So this is absolutely not possible right now because these systems like, the system that I showed or Bing Search, they're only able to answer pretty simple questions. So we're going to have to move from understanding simple facts to understanding entire research papers. We're going to have to move from the very basic reasoning that we can do right now over simple, very clear facts into reasoning over complex and uncertain assertions from research papers. And I'm pretty certain that language models will be a critical component of future language systems, and that we're not going to get there by just scaling. Yeah, that's it. Oh, and this whole thing is on my GitHub. If you go, let me show you now. If you go here, our datasets are here, and then if you go to self-ask with Google Search, it's a short IPython notebook where you can run the system that I showed you and play around with it. Okay, that's it. If there are any final questions, I could take them now.
Thanks. So Mohit has a question.
Yes.
Yeah. First, thanks for the talk. It was super interesting. One question that I have is, so we know that these instruction tuned RLHF models are capable of, I guess at least intuitively, they seem capable of more advanced reasoning than just a normal pre-trained language model. Do you think that, you know, the data set that you have and the experiments that you showed, do you still observe this compositionality gap with models that are you know, learn from human feedback or instruction?
Oh yeah, we actually have in the paper we actually compare these side by side. So this is the compositionality gap for GPT-3 models that are not instruction tuned. So that's what I showed in this talk. So it's 40%. And then this is a compositionality gap for all the instruction tuned models. And it's 40%. And it's still 40% in ChatGPT and in DaVinci 003. So instruction tuning, it doesn't really seem to narrow this reasoning gap. Yeah.
Interesting. I guess if you tuned the model on examples that require it to produce follow-up questions and then reason over them, which probably OpenAI has been doing in other companies.
Yeah. But the reasoning gap doesn't give the model an opportunity to think things through, right? In the reasoning gap, we just want to see if it can answer the compositional questions directly without thinking things through. We just want to validate its performance on that, right? So even if you did fine-tune your model on chain of thought, which OpenAI does, it doesn't help you here, because here we're not giving you time to think. We're asking you, you know, what is the coin code of the birthplace of Plato? And your next token has to be the answer. We're not giving you time to think.
I see. But what if the default behavior of the model, even if you give it a question without any sort of prompt or instructions, is to actually do this, like provide a reasoning of your
in this evaluation, that would not be reflected, because we're asking you to immediately answer the question, right? So we're really, yeah.
Do you think that is fair?
I think it's an interesting thing to look at. You might say that it's not the most important thing in the world. The most important thing is seeing how well it does on chain of thought. But I definitely think it's an interesting thing to look at, because, for example, in some cases, the model doesn't realize that it needs to start chain of thoughting things, and it just answers things immediately. So
right.
I think evaluating this is definitely interesting. But you're right that it might be a bit unrealistic in some scenarios, but I do think it's still an interesting thing to look at.
Yeah, thanks. And one small other question is, do you observe cases where when you ask the model to write these follow-up questions and answer them, it actually gets the wrong answer, and it would have got the right answer if it just didn't do this? Because I think this is a problem with some of the chain of thought cases where it gets all the steps right, and then at the end it just outputs the completely wrong answer. So perhaps there's some behavior like that you've observed.
I didn't really see that. No, when it gets the sub questions right, it'll answer the main question correctly. But sometimes it doesn't know how to decompose a question. I mean, I don't even know. Yeah, like sometimes it just decomposes them in a weird way, but it's pretty rare. But sometimes it, like, I have this question in Bamboogle, which is how much protein is there in 4 boiled egg yolks? And Google gets this wrong. And then GPT-3, if it were to decompose this right, it would get it right, but it doesn't decompose it into how much protein is in 1 boiled egg yolk, and then what's that times 4? It doesn't do that. It decomposes into something weird, and then it ends up not answering it correctly.
Okay, thanks.
Final questions?
Does anyone else have questions? So I had a question about have you tried changing the temperature or the variability in the
Yeah. Are you guys here? Did we disconnect or did they disconnect? Did I disconnect?
No, I can still hear you.
Oh.
Yeah, I think the server
disconnected.
somehow had issues.
So,
Yeah.
oh, there we go. I'm back.
Sorry, we lost you for a few seconds.
Yeah. I heard the question. Somebody, sorry, go ahead. Go ahead.
Yeah, I think Erika was asking a question when we lost you.
Yeah, go ahead.
Yeah, it was about temperature.
Oh, yeah, I heard the question.
Yeah.
We experimented a bit with not using zero temperature and it didn't really seem to help, so we just settled on zero temperature, but I'm up for being proven incorrect, so yeah.
So I think that Catherine had an interesting question.
Okay.
This I guess goes back to, sorry, maybe the Bamboogle egg yolk question that you had, but I was curious if the syntax of some of the multi-hop questions could just be particularly difficult for to just parse, and if the decomposition of those is just like the decomposition of that really tangled syntax makes it easier for the model to predict the next token like on its way to the answer without like doing any actual reasoning. And I guess like a kind of follow-up question to that would be, did you notice any differences in the kind of syntax of the questions in your data sets that were particularly challenging for the models?
No, yeah. Why do you think the syntax of the egg yolk question is tough?
I don't think that one in particular is tough, but I'm just thinking in general, like multi-hop questions are not a very natural way to ask questions.
Yeah, most multi-hop questions are really unnatural, and like one of the data sets that maybe both of them, Music and 2 Wiki multi-hop, they have like 3 or 4 hop questions, and we totally didn't look at those because they're totally unrealistic and just silly. I do feel like 2-hop questions, the 2-hop questions that we asked in Bamboogle are pretty natural. So I don't think that there should be any issue there. And in general, the 2-hop questions in the data sets that we use seem pretty parsable. So I don't think that that's an issue. And I also noticed that the model, except for that egg yolk question, I don't think I can remember any examples of the model screwing up the decomposition. It does happen, but it's pretty rare.
It just feels like these multi-hop questions are like as close as you'll get for questions to be these like garden path sentences where like the syntax is very different from what you actually think it will be, and that would be particularly difficult for a model that generates token by token.
Yeah, multi-hop, that's why we didn't use hotbot.qi, because I thought that the questions were way too artificial, and multi-hop question answering datasets can get very, very silly. That's why we made our own one, and we tried making sure that the questions there kind of seemed reasonable and easy to parse. But yeah, it's definitely something to watch out for. Multi-hop question answering datasets can definitely be very weird.
Thank you.
I had a question. Yeah, hi, okay. I had a question that's kind of related. I guess I was wondering how your experiments. So I guess in the paper you're concluding that the experiments show there's a compositionality gap or like a reasoning gap, and however one may define what reasoning is. But I was wondering how you can differentiate that from like parsing, like Catherine was saying, just like a parsing gap for the model, and also, or just like the ability for the model to accurately assess or like triage the query for how much computation to apply to the question, versus actually the model's ability to like combine stuff, because clearly it can combine stuff when it uses self-ask. So
I don't think I understand your question.
so I guess
Maybe-
how, yeah, so like from the experiments in the paper, I guess I feel that it might be possible that it's not like a reasoning or a compositionality ability of the model, but more so
Yeah.
the ability of the model to accurately assess how much computation to apply for a specific question. So that's not really a compositionality problem or like a reasoning thing at all. That's just triaging the query. Or if it's like a parsing thing, like having to understand a really convoluted sentence, that's also a completely separate ability from compositionality.
No, I think those are all the same thing. Like if I ask you a question and I'm just gonna put it under compositionality, especially because I've reviewed all these data sets and I thought that the questions were not hard to parse. And
okay, I guess I
took
did
the-
actually. There are
Oh,
like definitely a few
interesting.
questions that I thought were kind of
Interesting.
weird, and like just like I had to read them a couple times.
Interesting. Yeah, I don't know. I still think it's a reasoning issue if the model can't solve them, but yeah, maybe the right way to solve this is to first have the model rephrase them in a simpler way and only then ask it to solve them.
Okay, thanks.
I think Mungshe had an interesting question. Okay.
Maybe you can just ask the question.
Yeah, that's good. So there were two interesting questions. One is, how do you choose the prompt examples? And another is, do you have any clue why the compositional gap exists and doesn't decrease with the increasing size of the language model?
How did I choose the questions for the prompt? That's a good question. I just tried to have questions. So when I was working on music, it's one multi-hop question answering data set. I noticed that it had like, 4 or 5 different categories of questions. And so I just picked one example question from each category for the prompt. But it's not really important when we designed the prompt for 2Wiki multi-hop to show that you don't actually need to really do a lot of prompt engineering here. The example questions for the prompt are the same 4 example questions in figure 1 of that paper. And when we did Bamboogle, we just took the same prompt that we used for 2Wiki multi-hop and we used that for Bamboogle. So you just need a few examples, and it doesn't seem to, like, these models are really strong, and even if the examples aren't really chosen well, it can still work very well. Why is there a reasoning gap? I don't know. There's a reasoning gap because it doesn't think things through like a human. Right? If you ask me a compositional question, I kind of reason about it in my head. And only then give you an answer. But language models can't really reason in one time step. They can only reason by talking things through. And so when you ask it, what is the calling code of the birthplace of Plato? Just like somebody said before, it's probably like thinking, okay, I saw calling code, Plato, he's from Greek, like it kind of says, okay, let's just output the calling code of Greece, but it can't really think deeply in just one time step. So if you want it to think deeply, you have to get it to talk things through.
Just to branch off of the prompt example question, have you tried having examples with different numbers of hops and just very different phrasings of questions? And are there certain choices that would affect different performance of the method?
Yeah, well, we don't have any experiments for that on the paper, but I just showed you guys an example where our prompt is only 2 hop questions, and then we can still answer 3 hop questions. So that works. Yeah, but we didn't experiment too much with that in the paper.
I think Cho had an interesting question. You remember?
Yeah, so I'm just wondering, just let us know if you can hear this because Cho is sitting. Oh.
Yeah, I can hear.
Yeah, so I'm just wondering, like on average, how many follow-up questions does the model ask before returning the final answer? Like, is it like just 2 questions, 2 follow-up questions for 2 hops, or is it like more than that?
No, it's in the paper. Yeah, we experimented only with 2 hop questions, and it always asks just two follow-up questions. In some cases, it may be asking more in very rare cases, but yeah, it's mostly asking 2 follow-up questions for 2 hop questions.
So Jake has an interesting question.
So have you tried GPT for the setup?
Yeah, we're in the process of running that right now. We had an initial experiment on a small subset of questions, and I think the compositionality gap was 20%. So we tried this with ChatGPT first, it was 40%. We were like, we still got it. And then GPT-4 is 20%. But yeah, we don't know why. We don't know if it's because they trained on much more data. We don't know if it's because the model is much bigger. We don't know if it's because the model is a totally different type of architecture. There's some rumors that GPT-4 is a mixture of experts model. We don't know if it's because they did RLHF on different, we have no idea why, but there's still a gap. It's still pretty significant. It's 20%, but it has shrunk. So, yeah, that is a preliminary result. So it might be wrong, but I'm pretty sure it's not. But yeah, there's still a gap, but it might be shrinking.
Thank you.
Yeah, Mohit has a question.
Yeah, I also wanted to ask about the limitations of the setup that you currently have, where all of the answers are entities or like short, I don't know, numerics maybe, but it seems like for long form questions, there's a much vaster space of reasoning abilities the model would need to, and it's not really clear if the setup is could help in those cases, mainly because evaluation is very challenging as well. But I think it is I mean, I was curious if you've thought about expanding to more complex QA tasks.
That was the entire point of this, right? So I was super excited about chain of thought, but chain of thought in their original paper, they only showed results on very, very artificial questions. It was only like arithmetic or like date format changes. It was like very, very artificial. And so one of my intentions with this paper was to be the first person to kind of apply chain of thought to slightly more realistic things. And that's why we did question answering. But yeah, of course, the next step here is to do kind of tougher question answering where the answer is a few sentences or a paragraph. That's a super interesting direction. I've started working on this, but I have not made a lot of progress, mostly because I'm not sure how to evaluate this and what questions to ask. And but yeah, I think that's the next big thing here is understanding how to use chain of thought and self-ask style reasoning to write entire paragraphs or more.
So for example, like the quality data set has these very complex questions that, even we are working on ways to decompose them, but it's extremely challenging, right? Because the chain of reasoning that you might expect is completely non-trivial for these kinds of questions. But yeah, maybe there needs to be more benchmarks like that one to enable this kind of study.
Yeah. But yeah, I think the right approaches for answering those types of questions, I think they must be chain of thought and self-ask, because that's the only way to get the model to kind of think things through. And just like it helps for these very limited questions, I think it must help for even more complex ones.
So Hugh has an interesting question.
Hi, I just have one question. So, do you think in this setting, like few shot will work better, and then just one shot, like when we just guide the model one example of it, or when we give more example, it will work better?
Yeah, we didn't experiment with this enough, but it seemed like if you were asking a question that had very, very, very different reasoning than what was in the prompts, it might be hard for the model. So adding another example that had similar reasoning to your test time question would improve results. But after some point, it didn't seem like adding more examples would help.
Thanks.
Ishao, do you have a question that you can
Yeah, so you just mentioned that scaling up the size of models might not work for long term. So what is your suggestion maybe to improve models' ability in reasoning? And in particular, what do you think about modularity? For example, like human brain, it has different area for different functions, and they work together to enable us to reason. And there's observation in human patients that you don't need to be very smart to speak a language very fluently. There are patients that they are intellectually disabled, but they can speak very well. So maybe there's some other way, instead of improving this model language, maybe we can add some module to add in some ability and then make them work together to do the task of reasoning. So what is your take on this?
Yeah, I'm very excited about systems that combine language models with external tools. And so in this paper, I showed how to get a language model to very easily interact with Google Search. But you can also add in a Python interpreter. You can add in other things, all kinds of other APIs. And yeah, I'm very excited about those directions, and I think that they're the way to go. But yeah, that's how I would approach modularity. Yeah, when I was working on like quality questions, it was built on top of my self-ask plus Google Search system. So you have the language model for like doing reasoning and Google Search for retrieving information. I think that's the right way to go.
So you believe language model alone can have this, already has this strong ability of reasoning. We just need to find a way to elicit that ability?
Yeah, and help it do better reasoning by better prompting it. If you prompt it badly, if you prompt it to answer questions right away, it won't do well. But if you show it examples of how to reason, it's going to get better at doing that.
Then it feels like it's not the model that is reasoning, but human is trying to like reason and then show the model to do such a thing.
Sure.
Whether there's a way for model to figure out such a thing.
I mean, everything the model does is because of humans, right? It's trained on text that was written by humans. I don't think it's bad to kind of show it how to reason once and then have it do it an infinite amount of times at test time.
Thank you.
Does anyone have any last questions? Okay.
Just following on to Yisha's questions, do you think it's worthwhile at this point to work on different pre-training objectives and architectures that might lead to better learning abilities without all of these techniques that you're mentioning? Or do you think there's potential if someone were to be able to do these experiments at scale? From your perspective, as someone who has worked on these things for a lot of years and then can no longer do so, how do you feel about that?
Anybody who can't train 7 billion parameter models should not work on new architectures, because the research that they do will have a very, very hard time convincing the community. It's very, very sad. But so basically what I found is that a lot of results on 100 million parameter model, or even 400 million parameter models, do not translate to 1 billion or 2 billion parameter models. And so a lot of people in academia right now are kind of working on new architectures, and they show results on 100 million parameters. And they have a very tough time selling that to the community, because a lot of people kind of know that those things are just not going to transfer up. And so, yeah, it's kind of sad. But right now, I do not think that academics can do architecture research that will have impact. I do think that this is a temporary thing, because in like 2 or 3 years, 7 billion parameter models are going to be much cheaper to train, and they're still going to be very strong. And so maybe at that point, we'll go back to doing architecture research. But for right now, I don't really see how somebody who doesn't have the budget can do that. But if you do have the budget to train 5 or 7 or 13 billion parameter models, you definitely should do architecture research, because there's still a lot of things to discover, especially as we start thinking about models that can handle larger sequence lengths and images and videos maybe at some point. Like, there's so much to do in the architecture space. I can't wait for computers to get faster so that more people can participate in that research.
Are there any other last questions? Is there a question on Zoom?
Have I tried abstractive question answering? I have not tried abstractive question answering. Have I tried self-ask on math questions? Yeah, we've run self-ask on like arithmetic and like algorithmic style reasoning, and it works pretty well. But we don't have those experiments in the paper.
Yeah. Thanks a lot for your talk. We do have to wrap up and leave the room. So I think that's it for today. But yeah, it was really interesting. Thank you.
Thank you so much, everyone. Yeah, and feel free to reach out to me on email if you're working on this type of stuff. I'm always available. Yeah, thank you so much for coming.
Thank you.
Bye-bye.